Hello everyone. In this video, I will go over my solution for the constructive problem taken from today's Codeforces round. This is an excellent problem which will teach you how to increase the minimum excluded element of an array by 1 by performing an operation in which we set a range of elements of the array equal to some constant k. So we need to do this for any given range, and by performing this operation, we need to check whether we can increase the max of a by 1 or not. So we need to print yes if we can do so and no otherwise. So let's take an example. Let's say we have three elements 1, 2, 1. Then clearly the initial max of the array is 0 because 0 is not included in the array. So m is 0, and we want to make sure that m becomes equal to 1. So that's why in order to make m equal to 1, we will just have the number 0. We'll need to have the number 0 in the array, and we'll need to make every other element equal to like less than 1. So we need to ensure that 1 is not there but 0 is there in the array. So we can set all elements of the array to 0, and this will give us a max of 1. Now in general, for a max of m, if we have max equal to m, then we know that all the numbers from 0 to m minus 1 are there, but m is not there. And if we want to make the max equal to m plus 1, we want to transfer that to m plus 1. This means that we need to ensure that all the numbers from 0 to m should be there, but not m plus 1. That's why we can, let me take another example and then I'll explain the general idea. So in the next example where we have 0, 2, 2, 0, the initial max is 1 and we want to make the max 2. So if we start off with 0, 2, 2, 0, the max is initialized to 1 because 1 does not exist in the array but 0 exists. Now the optimal idea is we need to ensure that m is equal to 2 does not exist in the array. So that's why we need to make all the elements which are equal to 2, we need to change them to 1. That's what we do over here. And then we get a max of 2. Even in the first example, we consider the entire range of elements which have 1s, and because we want the max to be equal to 1, we need to ensure that that number becomes equal to m instead of m plus 1. So wherever we have m plus 1, we replace m plus 1 with m if m plus 1 exists anywhere in the array. So if m plus 1 exists, then we replace m plus 1 with m, and that's the first key observation which is required to solve this problem. The second observation which is required to solve this problem is that if m plus 1 does not exist, then clearly we know that uh, we need to ensure that all the numbers from 0 to m appear, and all the numbers, so we know that 0 to m appear, and we need to ensure that initially 0 to m minus 1 appear, and we need to add m somewhere in the array, and we need to add m. So we can do this by noticing that we can change only one element. So we just change one element from some number to m, and we can do that because an element can be a single element can be the range I to I, where I is the index of the element in the array. So we just choose any one element and we change that one element. Now this condition will be met only if frequency of x, so over here f of x refers to the frequency of x. So if some x exists, if frequency of x is greater than or equal to 1 for some x greater than m, then this means that we change x to m. Otherwise, we check if frequency of x is greater than or equal to 2, for some x less than m. This means that we change one occurrence of x to m. And the reason why this works is because in the first case, anyways, all numbers greater than m don't matter. So we can change any one of them into m. And in the second case, since we need all numbers from 0 to m minus 1 to appear in the final array as well, that's why we need some number to appear twice. And that's why we just need to check whether any number appears twice, at least twice, in the array so far. So this is how we handle the second case. In the second case, when frequency of m plus 1, so if frequency of m plus 1 is equal to 0, we go to the second case and we perform these two check operations by checking for these two conditions. But in the first case, when frequency of m is not equal to 0, we find the first occurrence. So find the first occurrence of m plus 1 and last occurrence of m plus 1, first and last occurrences of m plus 1, and we make the entire range, this entire range from first to last, we change that entire range to m. So we replace it entirely with m, and in that way we can ensure that we are making sure that all the numbers from 0 to m appear in the array, and that's why the max will become equal to m plus 1. And obviously, in both the cases, we can just run a final loop to check whether the resultant array actually has a max equal to m or not, m plus 1 or not. So that is the entire approach for this problem. And now I'll show you the code which basically implements these two cases. So in the code, I use fast IO for each test case. I taken the length of the array, I taken the elements of the array, and this is frequency of elements. I also maintain positions of all elements, but this is not really needed because we only need the first and last positions, first and last position of max plus 1. So that's why this is a wasteful extra variable, but I used it in my first go. So for each element, I taken AI, I taken the frequency of AI, increase it by 1, and I push back AI to the set of all positions. Then I initialize max to 0, initialize max to 0, and I compute max by checking for the first for the first element which doesn't appear in the array. So that's how I compute the maximum that's how I compute the maximum excluded element in the array, by basically checking which element does not appear in the array. And now over here, if max plus 1 does appear, this means that we need to change all occurrences of m plus 1 to m, and we do that by finding the first and last positions of max plus 1 and updating the entire range. And in the end, we compute the max. So recompute max and check if max is equal to max plus 1 or isn't max plus 1. And if it's so, we print yes, otherwise we print no. And this is the entire first case. So in the second case, when max plus 1 does not appear, this means that we need to check for a number greater than m or a number appearing twice less than m. So we do that by basically checking for each number from 0 to m minus 1. If it appears at least twice, we set the Boolean variable to be true. Otherwise, we iterate through each element in the frequency list, and if the frequency of that element is greater than or equal to 1, then we again set is to be true and we break. So this is basically check if a number greater than m appears in the array. And once we do this, is stores the flag of either true or false, depending on whether the max is equal to max plus 1 or not in the end. And depending on whether or not max becomes equal to max plus 1, we print yes or no. So this is the entire approach and the code for this problem. If you have any doubts on any part of the solution, do leave them in the comments down below. And if you like this video, don't forget to give it a thumbs up. Thank you.